guys, I'm Ernest. Welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept in reaction rates and reversible reaction, and that is the concept of equilibrium. Now, this concept of equilibrium is as well very important because we said in altering the aspects of temperature, pressure, and concentration during chemical reactions, we're going to dictate on how that particular chemical reaction is going to take place. Now, the concept of equilibrium from what we had already discussed about the reversible reaction also is one of the ways in which we can be able to achieve the maximum yield, especially in industrial processes. So this finds one of the applications in industries whereby we have to check on the concept of equilibrium in order to attain the maximum yield. So for today, this equilibrium, I'm going to illustrate this one using the specific equation that I've drawn on the board, maybe another illustration that is going to be relevant to us. So thank you and welcome. So for our discussion today is the concept of equilibrium. And when we were talking about the concept of reversible reactions, we said that a reversible reaction is a reaction that can be which can be able to change the direction of which it is proceeding. And we gave an example, and one of them was the equation that I've written on the board of the formation of ammonia and hydrochloric gas from ammonium chloride. And we said that reactions can be made to go either direction by changing the conditions such as temperature and pressure, or maybe concentration can be regarded as reversible. So this aspect of temperature, pressure, the concentration, and the state of reactants are some of the factors that we said which affect the rates of chemical reactions. And these are very important in industrial processes in trying to achieve the yields, as we have said, they maximize on the yields and maybe reduce on production cost, etc. So therefore, in the concept of equilibrium, we're going to say that there's a point whereby these particular two processes for the forward and backward reaction is going to attain a particular state, which we are going to refer to as equilibrium. Now, from the example that we have given on the board, we can be able to use this one to try and discuss that one, whereby if we try to increase the temperature in this specific reaction, when we have ammonium chloride, we're going to see that ammonium chloride that is present is going to decompose to form ammonia and a hydrochloric gas. So basically, if we were to write a forward reaction excluding the reverse reaction, we're going to have this one appearing as this. So these are this is the reactant, and these are the products that are formed after subjecting this one to increase in temperature. So at first, when this reaction is taking place, we are going to see that the forward reaction is going to be faster due to the high concentration of the reactants, which is ammonium chloride. So basically, as we talked about the factors which affect the rate of reaction, as the reaction starts, the concentration of the reactant is going to be higher. So therefore, the increase in temperature is going to favor the forward reaction, therefore leading to the formation of the products of ammonia and then hydrogen chloride. Now, once the products have been formed, we're going to see that there's going to be a reverse reaction which is going to start due to the combination of these two specific products to form a part of the reactant, but at a slower rate. Now, as that one proceeds, the concentration of ammonium chloride will of course start to increase. But from the first case, we are going to see that due to the formation of the products, the concentration of the reactant is going to decrease as the products are formed. But once there is at a particular point when the products start combining again to form the product, to form the reactant, the concentration of the products is going to decrease as the backward reaction is going to be favored in that particular case. So the variations in concentration for both the forward and the negative reaction is going to change, but there's a point that is going to reach whereby the rate of the forward reaction and the rate of backward reaction are basically going to be the same. So I can just write the point equal. So basically, they are trying to state be a point whereby the concentration of the reactant will decrease to a point whereby the formation of the product is no longer favored, and the products are going to combine to form the reactants in a way that the concentration of the product decreases and the rate at which the reactant is being formed equals to the rate at which the products are formed. So at that state, we'll say that they have attained a state of balance. So when the forward reaction equals the backward reaction, and this basically refers to the concept of rate, as we said that we can be able to measure the change maybe at the speed of a chemical reaction using the rate. So when the rate of the forward reaction equals the rate of the backward reaction, then we say that this particular chemical reaction has attained a state of balance. And at this specific point, we're going to see that the forward and the backward reaction in the state of are in the state of balance that we're going to refer to as a state of equilibrium. So this basically refers is a derivative of the term equal. So equilibrium means that the rate of the concentration on both sides are equal. Now, different from this specific representation, we're going to represent an equation that is showing the point of equilibrium, or maybe a reversible reaction that is equilibrium, that is going to be written as NH4Cl, half arrow for reverse, and then there's a formation of ammonia plus HCl. This is a gas, this is a solid. So that one is going to show that both the products and the reactants are proceeding the forward and back reactions, back direction respectively, and the two are at the state of balance. And therefore, at this specific state, we will say that the reaction is said to have reached what we call dynamic equilibrium. So at this specific point where there is a state of balance for the forward and back reaction, we say that the reaction has attained dynamic equilibrium. So therefore, this concept of a dynamic equilibrium will result because the reactant and the products are in a constant interchange from the product to the reactant, and vice versa. Now, there are some factors which, of course, we have said that are going to affect this particular concept of equilibrium, in a way that if these reactants and the product, or the forward and the reverse reactions, have attained a state of balance, if one tries to alter the concentration of either the reactants or the product in one way or another, then the reaction is going to proceed in a new direction, favoring a concentration where there is a less concentration of either the products or the reactants. So in that case, that one means, in any case, if I increase the concentration of ammonium chloride, it will favor the forward reaction to form this product. Now, suppose I increase the rate of, the concentration of the product, then that is going to favor the backward reaction to form the reactants. And that is what we, of course, are going to refer to as one of the factors that are going to affect this state of equilibrium, is the altering the concentration of either sides for this specific reversible reaction. So in this case, apart from the change in the concentration that we have mentioned, of course, with other factors that I've already said, altering the temperature as well is going to change, alter the direction of that particular reaction, and as well pressure. So we have already mentioned this specific concept in one of our discussions in a video of the rates, reaction rates. Of course, I'm going to put a link in the description box. Kindly check and follow on that link in order to maybe check on that specific video. So I hope that we have understood what the concept of equilibrium means. And as we have said, as we discuss these various topics, they find maybe wide applications in our day-to-day life, especially in trying to optimize the production of a product or maybe an industrial product and trying to optimize the yield. Therefore, we're going to explore this concept of reversible reaction by maybe trying to alter some of these factors that we have talked about, and that is going to assist us maybe in minimizing the cost or trying to achieve maybe convenience. So in this case, I hope that we have understood what the term equilibrium means. So in any case, if we are in a discussion and mention about the concept of equilibrium, I hope that this video is going to be of help to us. So before I close, I'd like to encourage our new members. I'm going to give a thumbs up for you and encourage that you invite other new members to our group so that we can be more and assist one another in trying to find solutions to some of the challenges, especially on the topics of mathematics, sciences, and etc. So for that case, thank you. Bye. God bless.